Hello everyone, welcome back to Simple Networkings. In this video, we are going to see how to configure the EIGRP in the Cisco Packet Tracer in the detailed way. Before going to the Packet Tracer, we will see some basics of EIGRP. So EIGRP abbreviation is Enhanced Intermediate Gateway Routing Protocol. It was a Cisco proprietary protocol. Now it is an industrial standard protocol. Previously, EIGRP we can configure only the Cisco routers. Now we can use all the other vendor route like Juniper, HP, all the routers we can use the EIGRP. EIGRP is a popular routing protocol and many enterprise network we are using because it is combine of the distance vector and the link state routing protocol. This is very advantage. So most of the enterprise networks we are using the EIGRP, and this is a interior gateway protocol. And EIGRP is a advanced distance vector routing protocol that is used for the automatic routing decision. And EIGRP is a hybrid protocol. Hybrid protocol means this protocol is mainly designed from the distance vector and the link state protocol, and the using algorithm is diffuse using updated algorithm. We see some key features of the EIGRP. EIGRP is a rapid convergence protocol. Rapid convergence means within fraction of second the link will be switched over. EIGRP sends only the partial update when there is a change in the network topology because reducing the bandwidth needed for the routing protocol traffic. The second one is the advanced metrics. If you see it for RIP, the metrics would be hop count. For OSPF, it is bandwidth, but here in key value is the we have some key values. So key value is starting from K1 to K5. So the key value is bandwidth, delay, load, reliability, and MTU, maximum transmission unit. So which will allow for the more intelligent path selections to compare with the simple hop count metrics. So this is the key advantage. The other one is the equal cost load balance. If you see for the OSPF will support the load balancing, but it will support the equal cost. But ERGRP has ability to perform the unequal cost load balancing, allow the traffic to be designated across the multiple path of the different metrics. We will see the ERGRP port number and the AD value. So port number is 88 and the administrative distance is 90. And the multicast IP address of the ERGRP is 224.0.0.10. Now we will go to the Cisco packet tracer and we will configure the ERGRP from the scratch. So I'm going to explain in the two scenario, which is the normal scenario. Another one is how equal cost load balancing will be happen and the how the rapid convergence is happen. So I'm going to explain the two things in the two different labs. Let's get started. In this topology, we are going to configure the EIGRP. So just assume we have three branches, branch 1, branch 2, and branch 3. The three systems are connected into the branch gateway router, and this router is we are going to configure the EIGRP. Now the configuration is done, only the basic configuration. So just to quickly I will explain what is the configuration I have done. So in this PC, just assign the IP address, and this is the interface IP address, and this IP address I have used as a gateway for this switches, I mean this PC. Same way this setup branch 2 and branch 3. Okay, so only the basic configuration is done. So basic configuration is only the IP address is assigned and the interface is turned on. There is no other configuration. I will just quickly go to the router. I will show you the show running configuration. We will get some idea. If you see here, show running configuration, only the interface is assigned and the port is turned on. There is no other configuration. Now I'm going to configure the EIGRP. So first we will configure the branch one of it. So what I'm going to do, I'm just going to do config the host name. I'm going to give us branch one for the identification. Okay, branch one router, then router EIGRP 1. So this is the autonomous system number 1, and the same autonomous system number 1 we need to give for the branch 2 and branch 3 router. If the autonomous system number is different from one branch to other branch, then EHRP will not communicate. Okay, this is done. Then we need to advertise the one network. So network, then we need to give the IP address. So what is the IP address is 192.168.1.1, 192.168.1.1. Okay, we need to give the wildcard mask. If you not give the wildcard mask, this is class C subnet, so the slash 24 IP address, the slash 24 range will be automatically taken care. Okay, this is done. Then we need to advertise some one more network. So the other end network is 192.168.10.1. 192.168.10.1. Okay, this router configuration is done. Now going back to the branch 2 router, the configuration will be same, only the network range will be differ. Config t, host name, branch 2, router EIGRP 1. So we have given the process AS number is 1 in the branch 1. So we need to give the same one. Then network. So here we will see what is the network is configured. So here we have configured 192.168.2.1, 192.168.2.1. Then another network is 192.168.10.2, 192.168.10.1. Okay, so automatically once I added the configuration, the neighbors is starting up. So I need to add one more range. So the other range is 192.168.20.1, 192.168.20.1. Because this router we are using three different subnet because this is connected into the middle of branch 1 and branch 3. Now going to the branch 3 router, enable config 3, enable config 3, hostname branch 3, router EIGRP 1, network 192.168 3.1, 3.1, then network 192.168.20.1 we need to give 192.168.20.1. We can give wildcard mask, like if you use /24 means we need to give 0.0.0.225. But if you not given here, so the default /24 will be taken care. If you see here, now the EHRP is came online. Okay, so we have some commands. So show IP EHRP neighbor to see the neighbor table. Then we can see, if you see here, neighbor topology to see the router. Okay, if you see here, I'm not used any wildcard mask. At this is class C range, IP address range is class C, so /24 is taken, and these routers are the successor router. So in EHRP we have two type of one is successor, another one is feasible successor. Successor is the best path and feasible successor is the backup best path. In case if successor goes down, the feasible successor will come in the picture. So that's why this is the rapid convergence protocol and the advantage. And we have show IP route EHRP to see the routing table. Okay, so D stands for the EHRP. Okay, done. So same way we will just quickly see the things in the branch 1 router. Again, show IP EHRP neighbor, show IP EHRP topology. Okay, done. So we will just try to communicate the PC from this PC to this PC. So we will try to ping 192.168.3.1 command prompt, ping 192.168.3.11. The first packet generally it will be discard. The reason is the first packet will fail to advertise the network. So the second packet we are getting the replay. Okay. So I will just do continue pings hyphen T. Okay, to get the continue pings. This is topology 2. In this topology, we are going to see how EHRP is doing the rapid convergency as well as the unequal cost load balancing. So this two item we are going to see in this topology. So as usually, so only the configuration is done, the basic configuration is done, like only the IP address is configured to the specific interfaces, no other configuration is done. So we will just go and quickly do it. The remaining configuration, enable, show run. So if you see here, only the interface is done. There is no other configuration. So what I'm going to do, configuration T, host name. So just we'll make us branch one, then router EIGRP, one AS number, network. So we need to call three networks here. One is 192.168.10.20.1 dot. So 192.168.10.0, then 20.0, then 1.1, 1.0. Okay. And so I'm going to enable the debug command. Okay. Okay. Before doing that, I will just do the configuration. Let me show you the other configuration here, and I will config the hostname branch branch 2 router EIGRP 1 network. So we need to configure same three different network 192.168.10.20 dot. Okay, so before going that, I will just make it simulation. So I will show you the multicast IP address 192.168.10.0, then 20.0, then 2.1, 2.0 with three range. Okay, let's see. So this packet will see. So this multicast IP address is 224.0.0.10, right? So this is the multicast IP address for the EIGRP. So we are able to see these details and other details. And other detail, if you see here, EIGRP is version 2. Actually, we have two version 1 and version 2. Version 2, 1 is the very old one. It will not support so many multiple configurations. So version 2 is the one we are mostly using in the enterprise networks. Okay, I will make it real time now. So now the configuration is done. So I will just quickly see and the connectivity reachability. Then I will show you some couple of other items. So we will do 192.168.2.20. So what is this 2.20 is the IP address is this PC IP address. So I'm just trying to reach the PC3 from PC0. So this is the PC0, PC3 IP address. If you see here, go to desktop configuration items, see 192.168.2.20. So the same one I just trying here. I will just keep here, make a note here. Okay. Going back to this PC, yes, we are getting the reachability, and we will see how the traffic is going. Okay, because here we have connected two links, right? So we will see which the link is going. So for that, trace route, trace it, same 192.168.2.20. Okay, we will see. So the traffic is going 192.168.1.1. This is the gateway. Then after that, it is going to 10.2. So where is 10.2? 10.2 is this one. So how the traffic is going is from this link. I mean the fast Ethernet links it is going, not the serial link. Okay. So what I'm going to do, I will just disconnect the fast Ethernet link. We will see the traffic is going via serial link or not. Okay, so for that what I'm going to do, I will just make maximize here. Okay, ping hyphen t for continuous ping 192.168.2.20. Okay, so it will do the continue ping. I'm just going to do this router. So the interface is 0/0/1. So what I'm going to do, interface gigathanan 0/0/0/0/1 shut. Okay, so I made this shut. Okay, now if you see here, see the traffic is going here. There is no one packet loss as well. Okay, only the millisecond is getting changed because now we are tr- forwarding traffic to the serial link, right? So this what we are saying. EIGRP is a rapid convergence protocol. Within millisecond, if you see within milli of seconds, the packet is converging from one link to the another link. Okay, so the packet is pinging. So what we will do, we will just try to see the trace route. So previously it was going 10.2, right? Now if you see, it will be go via 20.2. Let's see how it is going. See, as we said, as we expected, the traffic is going via 20.2. Okay, now going back to the same router, okay, bringing that interface show not shut. So as I said, the EIGRP is a rapid convergence protocol and we shown in the lab. We will see some more details in the EIGRP in the debug command. So what I'm going to do, enabling debug EIGRP packets if you do it. Okay, so as we said, we update, request, query, replay, hello packets. This are the contents in the hello packets, right? So if you see every 5 seconds the hello packets are sending from each neighbor. Okay, so this is for the serial neighbor, this is for the serial, another one is for the giga ethernet. Okay, so what I'm going to do, I'm going to shut the interface, we will get the detail. Okay, so same way, this enable config the interface giga ethernet 0/0/1 shut. Okay, so the interface is shut. Now if you see here, I will stop the debug command so we can see the all the items now. If you see here, I have done the, I means I have shut the interface. So those detail we can see here. So it will send the update, it will send the query message once the neighbors is down. If you go up, scroll up, scroll up. Okay, yes. If you see here, till this one, okay, we are getting the hello packet. Okay, once we set the interface, it is giving this interface 0/0/1 is state is changed to down. Once this interface is came into the down, okay, if you see here, it is sending the query packet, right? So once the interface is went down, the EIGRP will send the query packet. So those detail we can able to see in this one. Okay. The other item what I want to show you is, if you see every 5 seconds it is going to be changed, right? So if you want to change the hello packet, let me show you how to change it. So what I'm going to do, I'm going to do no shut. Okay, so I will just start the debug here. Okay, debug EIGRP. It starts sending the hello packets. Okay, okay. Already we are in the Gigatnet 0/0/1, right? So now we want to increase the hello packet means. So we need to go to the interface. So already I'm in the interface 0/0/1. So here IP hello interval, then EIGRP, then the EIGRP AS number. After that, if you give question mark, it will be give the how many seconds we can able to trigger. So I'm just going to change it as 30 second here. So after changing here, if you see now, frequency is more in the serial cable, but if you see the Ethernet cable, the frequency is less. The hello packet frequency is less. The reason is we have manipulated the hello interval in this one. That's why we are getting timer into the this interface, right? Giga ethernet 0/0/1. So that is the reason here. So in this way we can manipulate the hello interval time in the EIGRP. Now we will see the scenario 2. EIGRP will support unequal cost load balancing. We are going to see this one. So for this I just made it as two serial cable to this router. So to ensure the connectivity, what I'm going to do, I'm just going to this PC, do the ping ping 192.168.2. 20 is the IP address of this PC. 20. Okay, so we are getting the replay. So what we will do, we will just do the continue ping here. Hyphen T continuous ping. Before that, we will see the how the traffic is going trace route 192.168.2.20. Okay, so the traffic is going 2.2. Oh, sorry, 20.2. 20.2 means this is going via this way. Okay, so if you do one, okay, so what I'm going to do, I'm just doing the continue ping here. The same way I'm going to do the ping for this PC. See, now I'm doing this ping for this PC as we to show the how the load balancing is happening. I'm going to do, see, for this PC I'm going to ping the same one. Okay, it is taking 10.2. Okay, if you see here this PC, it is taking 10.2. Okay, and this PC is taking 20.2. If you see here, it was taking 20.2. So in this way it is load balancing is happening. Okay, so here, so we can go this one, enable IP EIGRP neighbor IP show IP route EIGRP. Here if you see here, to reach the destination 1.0 means this destination we have two path. Okay, so it means it will be balance the load balancing even. So in this way only we are only the load balancing is happening in the EHRP. Also we have made the same kind of configuration topology video in the OSPF, and the link will be given in the description. If you would like to go to the OSPF Cisco Packet Tracer configuration, please go through the video. And if you like this video, please like and subscribe to our channel. Also, if you like to add any points regarding this topic, please feel free to write the comments in the comment box. Also, we will meet in the next video. Bye.